Hi everybody, good day my friends and students. Let's look at this question on the board. It looks a little bit corny, but if you understand it very well, we'll be able to solve it. Let me read the question. The question says, an electric lamp 240 volts 60 watts is left to operate for an hour. How much energy is generated in the filament? Before we begin to solve, I want us to have at the back of our mind the simple and the most common, or one of the most common formula in electricity, which is that electric power is equals to work done over time taken to do the work. I will simply say that power is equals to the same thing, energy. Energy is equivalent to work done. Energy over time taken to expend the energy. Power is simply work done over time taken to do the work, even in our daily life, in human beings, in machines. Power is the work done over the time taken to do the work. Okay, I will simply say it is energy expended over time taken to expend the energy. As I always explain, there are many things that do work in different parameters of life. Like I said, in offices, in companies, human beings do work there, machines do work there. Okay, so work is done by the workforce that we see in different parameters of life. Now, in the electric circuit, which is here as electric lamp, what did work is the material component of the cell. The material component of this electric circuit is what did work, or the material component of this electric lamp is what do the work. And what are the material components of any electric circuit? I will name them for you. One of them is, the first one I want to name is current. Current, which is noted by I. The next one is voltage. Voltage noted by V. And another one I want to give us is the time which the electric circuit is operated. The time which is operated noted by T. Okay. Now the work done in any electric circuit is the product of these three parameters: current, voltage, time. And as you can see on the board, power is equals to work done over time, which is equals to energy over time, which means that work done is equals to energy, or energy is equals to work done. I write it, energy is equals to work done. Okay. And the work that is done in electric circuit, as I said earlier, is done by these three basic parameters: the current, the voltage, and the time taken. Which means now that energy now, which is work done, is equals to now the product of these three parameters, which is current times voltage times time, is equals to current times volt times time, which give us equals to, I want us to use a symbol to represent it now, which is equals to, current is given as I, current is I, times volt is given as V, and time is given as T, so times T. We also know that I times V, which is current times volt, is equals to power. So this is equals to power, which now gives us that energy is equals to power times time. Which now gives us that energy is equals to power times time. I stop here for the moment. Now let's go back to the question. The question asks us, how much energy is generated in the filament? How much energy is generated in the filament? And we have known that energy is equals to power times time. Now let us check for the data given to us to solve the problem. The first data I see here is 240 voltage. Voltage is 240, so I write data voltage is equals to 240 V. This 240 V. Okay? Is there another data? Yes, we are given 60 watts. Power is measured in wattage. So we write power is equals to 60 watts. 60 watts. Okay. So we have as our data voltage equals to 240 volt and power equals to 60 watts. Is it complete? I think it still remains one. Yes, it remains time. Are we given time? Yes. We are told that it is left to operate for 1 hour, for an hour. So an hour. So time is equals to 1 hour. An hour means 1 hour. Yes. Because hour is not the standard unit of time. The standard unit of time is second. So before we use this time, we must change it to standard unit, which is second. So we're going to change it. We say 1 hour will be 1 times 60 times 60 again, because we are changing it from hour to second, which will give us what? It will give us 1 times 60 is 60. 60 times 60, 3,600. 3,600. Okay. Second, 3,600 seconds. So we now come back to our formula, which says that energy is equals to power times time. You have derived it from here and get that energy is equals to power times time. We begin to slot in these values into this formula, and we are asked to look for the energy. We are solving to get our energy. So I write energy is equals to, what is our power? The power given to us is 60 watts. So equals to 60 times, what is our time? The time is 3600 seconds. So times 3600. Okay, and which will give us for, let's calculate. It will give us 60 times 3600 give us what? 216,000. Okay, so our energy now finally is equals to 216,000 joules. Answer. Okay, which means the energy that is generated in this filament of 240 voltage and 60 wattage is 216,000. But I want us to note one thing. Because at the beginning I said this is a little bit corny, but if you understand it, we will solve it. We did not finally use, this 240 voltage given to us. No, we did not use it. It did not appear in the worker. Why? Because we choose to use the formula of energy equals to power times time. Yes, energy equals to power times time. That means we throw away this 240. And why did we throw it? We don't need it. If we insist on using it, then we now use energy equals to current times voltage times time. And we are not giving any current. I always say that's solved. There are always many ways to clear that. Likewise, there are many formulas to use to solve problems of math or physics. But the formula you will choose is determined by the data given to you. The one that is usable for you, data given to you. In this problem, we are given 240 voltage, given 60 watts, and you are asked to find energy. You are asked to find energy, and you know that the formulas for energy, one is energy equals to current times volt times time, and also know that another formula for energy, we derive it anywhere from here. That is energy equals to power times time. Now look at it. If we insist on using energy equals to current times volt, then we might be at loss because they don't give us a current. That is why we now use energy equals to power times time, because they give us power and then time. Yes, they give us power and time. So we now forgo this 240 voltage. Why am I saying this? At times they give you data in physics or even in mathematics. When you look at it, you look at the formula that you want to use. If any of the data, that's the information given to you, did not fit into the formula, don't use it. And always choose the formula that the whole information is provided for you to use. Always choose the formula. Any formula that the whole information is not provided for you, don't use it. Go for the formula that the information is completely provided. Okay? I hope you understand. So anytime you are giving question in physics and math, it's not a must that you must use the whole information that are given to you. That's where I'm driving to. That's what I'm saying. But if all of them is needed, use them. But if some of them is not needed, please make away with those ones and use the one that is needed. Yes, use the one that is suited for the problem. Yes. I hope you understand.